solving these problems. Where we are with JBroFuzz 1.1 versions later, some scripting capability and the roadmap. So, who in here knows what JBroFuzz is or does? One person at the back. Two. Wow. Okay, so JBroFuzz is a fuzzing tool that has been put together for the needs of penetration testing. So the basic principle is to be able to control the host, the header, the content, the body, the field, and fuzz those as variables using a number of payloads. This tool came out of penetration testing and has been in development for approximately now 22 months, roughly, give or take. So what does it do? If I just bring up, this is the jar file. It's written in Java. There's an executable, there's an installer, etc. Okay, so the basic principle is that we have the URL where we control the protocol, the host that we want to fuzz, the request. Here we add our payloads, and the output is logged at the very bottom. So if we were to just send a single request to the Owasp website, provided we have an internet connection, which is extremely slow, what we are sending is over HTTPS. So this is an HTTP request to Owasp of basically this. And what we got back, okay, what we got back was an IO error because the wireless internet connection isn't working. But the basic principle is that you have the request header fields here. You put a number of request header fields onto the wire, you track the responses, and you graph the output, etc. So in terms of really basic fuzzing capabilities, let's say that you had a web server that you were allowed to attack, and you wanted to test the version, the HTTP version number for integer overflows. How you would do something like that is you would go through the list of available payloads, and I'll come onto this. So let's say that we'd be testing for example, buffer overflows. So this will send all these payloads, which are a bunch of A's, nothing really complicated there. So it would actually replace the one value with the buffer overflow category. So if I click send here, again, we're going to get exceptions because the internet connection, okay, so the internet is up. So this is just putting a bunch of A's on the wire at the required field. Obviously it gets more complicated than that, but that's the basic principle. Request, header, any variables that you might have, put these on the wire, and be able to send more than 2 to the 16 plus 1 A's onto the Owasp website. And if we just quickly look at the graph of this in terms of file size, for example, so these are all the requests we send. Obviously we're sending a ton of A's and they're coming back. This is why this has gone back up. So in brief, we're trying to fuzz a web service or a server that's listening on either a normal connection or an SSL connection, and we're recording the responses, and then we're graphing them, etc., etc. So this is what JBroFuzz does in brief, and this is how it does it. So this talk, okay, so in terms of what we're actually trying to achieve from this, well, you can easily select these variables that you want to fuzz and replace the cookie values, check the response types, brute force post and gets if you've got in parameter values, etc. Check for any unsupported header fields, graph the results, and you can also script this up. Okay, so this is the basic 101. Now, in terms of the actual workflow, well, what we're doing is we are pretty much selecting the payloads that we want to go through here. And there's categories, and we'll talk about this. So we're selecting the fuzzers, we're sending the requests, collecting the responses, and this is typically the place where we spend all our time. That's an iterative process. We're revisiting the request and the responses, and we're comparing the results that we get. That's the basic concept 101 of fuzzing over port 80, well, any port, but a web service or a web server. So if you were to build a fuzzer today, in my opinion, you would need three things. You would need a stable and easy-to-use user interface. This is why most of the fuzzing tools, or some of the fuzzing tools out there, still use command line. It is the most stable user interface. You need a solid fuzzing engine, and a lot of work has gone into that particular section in relation to the Owasp testing guide, and in relation to what's a fuzzing engine. How do I define and group together the payloads that I want to send into meaningful categories? And you need to address the issue of, well, you're potentially breaking the protocol specification through the fuzzing request that you're sending, i.e. in HTTP, you can't actually send an HTTP/A. That's an invalid version number, and quite often the APIs don't allow you to do that. And I'll spend more time on this. So the likely problems that you're going to encounter, and this was roughly the situation that we were in terms of development around early 2007, is that, well, writing a user case for a fuzzer, what it does, is not actually a science project. It's not something that you can give to undergraduate students and they can go away and implement it. Maybe they can, but it's not textbook, because there's no definition, and especially a year ago when the fuzzing books for the industry were far, far less, there's no real defined process of what fuzzing is. If you look at the definition, you're sending random data to a service, a prompt, and you're recording the responses. Well, the data is not that random quite often. You know roughly what you're sending, and you know what you're expecting back. But how do you define that? So how do we solve the problem of the user interface? Well, we asked the Owasp leaders. Unfortunately, we got very, very contradicting results there. So let me give you some examples. If you ask Dennis Cruz what he wants from a fuzzer, it pretty much resembles the burp suite. And who in here is familiar with the burp suite? Good. And if you ask Dan Kulthberg, he'd just say, well, I just want to copy-paste the get URL and just go through a number of fuzzers. So there was some email correspondence there, and we went through all those responses. Unfortunately, they were contradicting, so you can't do one and the other together. Different people in this discipline have different ideas of what fuzzing actually is. You're going to have to rewrite the GUI components because, well, you want control over this huge data representation that you're recording. So you can't really do that through a NetBeans installer or a default GUI interface. You need control over the actual listeners, the sockets, and I'll go into this in more details. And also, you've got to accept some limitations. So if you send approximately, I don't know, 2 million fuzzing requests, well, you're not going to be able to row sort all those with 64 megabytes of heap when you're launching a standard jar file. So there's some limitations to address. That's the easy part, the user interface. Now, the real problem when it comes to fuzzing is that no one has, to my knowledge, defined how you group the actual payloads into categories and use those categories so that they represent the least amount of work that you need to do to achieve putting on the wire whatever cross-site scripting or SQL injection or hex enumeration or URL base 64, all the different encoding standards that are out there. So for this, there's an API, a core API, and the process around this API is to sort of standardize it into a framework for anyone that does want to do fuzzing, and that's the scriptable part. And also, in order to solve a problem of how do you group these payloads together, well, if you look at the testing guide, there's a long section of payloads in Appendix C, and they fall into two categories: replacive fuzzers and recursive fuzzers. And I'll come onto this, but basically, you're defining an alphabet when you're using recursive fuzzers, and replacive fuzzers, you're just sending literally a statement replacing the section of the code there. And obviously, one is a subset of the other. The final problem that you're going to encounter is that, well, you can't really use conventional protocol APIs that are out there. So let me give you an example. If you try to use a standard Java library of crafting a URL and opening a URL connection, and this URL connection has as HTTP version number that, it's never going to get on the wire, because that statement there is going to actually throw an exception. Okay, so you don't get as far as putting anything on the wire if you use conventional Java or similar APIs, because it breaks the protocol specification, and it makes sense. So how do you solve that problem? Well, I'm going to have to solve another problem first. Okay, so how do you solve that problem? You go a layer down. You implement everything as a socket or an SSL socket, and then you gradually build in the features that you want from HTTP 10.11.09. Now, you don't actually need to implement a full HTTP specification in order to fuzz. All you're interested is the terminating conditions of the protocol session. So you don't really have to worry too much about chunked encoding. You have to address it, but the work that you need to do when going from sockets to the protocol specification is far less than extending or expanding Java URL connection or the Apache HTTP Commons library. So these are the likely problems that you're going to have if you try to put together a fuzzer for web applications. How do we address these problems? Well, on the simplest of the categories, the user interface, have a graphical user interface that updates in real time, straightforward. Requests, responses in tables, so group them together so that you can sort them, etc. And also offer a bit of basic UI features, color coding, etc. Again, I don't want to spend too much time on this. But if you look at the first actually graphical user interface, which was coded in October 2006, you can see that it's a very basic GUI, and then little by little we start adding to it. There are different categories, and finally we reach the stage that we're at today, where pretty much you've got 3 different panels, etc. So all these are not defined. Even if you buy commercial tools, especially commercial tools 2 years ago, didn't have a grasp, firm understanding of what a fuzzer needs to look in terms of a UI. So in terms of the problems that we have in the core, and this is where it gets interesting, well, we need to be able to implement this concept of recursive and replacive fuzzers and use alphabets and actually group all these into categories and then open that up for developers to use it for their own code. So this is really the nuts and bolts of how core fuzzing has been standardized using what came out of the testing guide and really the need for grouping fuzzers into many categories. So if I bring up the actual GUI, hit the payloads tab. So how does this work? Well, we've got any number of categories, and these categories have a number of fuzzers inside. Each fuzzer is unique and has a number of payloads, and that fuzzer is recursive or replacive. Pretty straightforward. Now, each payload has a number of properties. And in this case, it's something very trivial and simple. But if we look at the cross-site scripting category, for example, all of a sudden you'll see, let's pick ASP.NET validation requests, recently broken. Okay, and here you have the exact payloads that you need. So here's a replace-if fuzzer, whereby you can, at the click of just adding this particular ASP.NET validation request fuzzer to a particular section of our request that we're sending here, we can very easily just check for ASP.NET validation if it's broken on a particular input parameter. Actually, this would have to be on a post request, so if we make this a bit more real, it would have to be this. And then the parameters would look something like, so this would be a typical example, let's say, of parameters. So then we would just, in order to check the form field, we would just add that particular category here, not selecting the equal sign. Okay, again, basic stuff. So where does all this actually take us? So what can we do with all this? Why are we doing all this? It's very often very good to have some stimulus to operate. So if I were to test, here's a typical example that I quite often quote. So here's the CIA website, and if we were to check what version numbers they support on their website, so in this case I would just add, there we are, so that 1 digit, I just want a base recursive base 10 fuzzer. So this will just iterate through all the possible 0 to 9 statements. Now if we do have an internet connection and it's going over HTTPS. Okay, so hopefully if we don't get, oh, excellent. Okay, so this is where it starts getting interesting, because all of a sudden you see a very popular website, and let's see what the results are here. So if again I pull up a graph of this, well, notice that we're getting actually a decent file size for an HTTP 00 request, right? That's an unsupported protocol that doesn't exist as a version number. So if we look at that, what's actually happening? Well, the CIA website is replying to that. Okay, and it's sending some data back. It turns out that even if you put 00 here, you can actually get some data back. So there's all these different fields in header requests, all these different fields in actual parameters which are not related to a username and a password in a post field, which are just susceptible to potential vulnerabilities. But because we don't have our hands on a decent API to fuzz them, quite often they get neglected. Again, this is not a vulnerability, but it could be a potential entry point. So, and just to prove the point here, if I do that, delete this. So the last request here is that, and so the CIA website officially supports HTTP 00. Again, nothing major, but it hints towards where we're going with this. Okay, so that's the motivation behind why we've put all this work to uncover all the different APIs, etc. By the way, if there are any questions, feel free to stop me and interrupt. Okay, so if we look at the implementation of the actual fuzzers, well, the payloads are in a file, and the file is distributed with the distribution of any new release, and basically in this file you can define your own payloads, etc. But you have a fuzzer that can belong to many categories, so it can be used from many different angles. For example, HTML encoding validation routines quite often have to be checked for both cross-site scripting and SQL injection because they could be different. And each fuzzer has to be unique, very basic. It has to fall in a category, have an ID, etc., and carries its own payloads. the final thing is that each fuzzer has to be one of the two. So we either go through replacing with the payloads, or we generate an alphabet concatenating and enumerating the different variables here. Okay, so if we look at the actual file, and this is what it looks like. So to give you the basic example, let's say that you found a prompt, and I think this is also in the write-up. Let's say that you found a prompt that only accepts DNA characters. Okay, so how do we iterate through all those in the minimum amount of code using something standard as a library? So if I just bring that up. Okay, so by adding these 4 lines here, 5 lines, you can see that we've just implemented the capability to go and select any one of, let's say, these statements and just iterate through what we specify in the alphabet. So this, again, is an enumeration exercise. So the first probably field is going to be ATC G, and then obviously we're going to iterate through that basic. Okay, so going back to the slides, so we've implemented a core fuzzing engine, okay, but how do we actually overcome the problem that we have with all the protocol APIs? Again, I've spent some time on this, recursive versus replacement fuzzers. So what are the problems that we have? Well, if you use anything other than sockets, you don't have control of everything that's on the wire. If you use sockets, then you don't know when what's coming in actually finishes and if it obeys a particular specification of a protocol. Now, because this is targeting HTTP, well, it has HTTP 1.1 has a bit of state, but not too much. So we're targeting a very small section of a protocol and seeing it from a higher layer, the layer of a socket. So if we were, let's say that today you started writing a fuzzer and you decided to rewrite the sockets to implement HTTP for fuzzing, what results would you need to overcome? Well, you'd have to implement the post content length rewrite. So every time you're posting something, if the length of the post changes, i.e. you've selected a parameter and you're fuzzing that parameter, then the content length of that changes. So you've got to take that into account, otherwise the request doesn't make it to the web server. And also, you've got to look at things like chunked encoding, where you get things back from the server, but you get them in little blocks or chunks. So again, this is much, much easier to do and actually implement through sockets. Now, going back to how can we use all this, and I'll be coming to this slide as well. Okay, it's all very good that we've implemented a jar file, but how can we give this to other people to use and implement their own fuzzers? So how do we make a fuzzing tool a potential fuzzing framework, something that other people can use? Well, people are not going to be interested in the UI interfaces that you've added and the color coding, nor are they going to be interested, especially if they're penetration testers, on how you deal with sockets, because they won't trust it. They will want to do it themselves. So it's worth actually giving them a core API that uses all the payloads which are in a file and allows you to group them in meaningful ways. So going back to actually scripting, and I'll spend a bit more time on this. Well, okay, this is a basic example, and again, you can do this in many ways. I've picked a hex fuzzer because it's straightforward. So let's say that you wanted to generate all the numbers in hexadecimal, 5-digit numbers from 0, 0, 0, 0 to all the Fs. Well, okay, there are many ways to do it, and this is a straightforward example, but what actually JBroFuzz does is it goes and implements the fuzzer class as an iterator. So you don't have to worry about where you are in your fuzzing. You just request a next element, and if that exists, you just access it. and you don't need to worry about the actual details which are there. So that's quite handy when it comes to more complicated things like URL, base32 encodings and base64 encodings, etc. Okay, so 1.1 versions later, so the version numbers obviously go up in increments of minor versions, 0.1 being the first one, 1 the last. There are 47 classes in 13 packages, a really small project, just 13,000 lines of code. And some key conclusions: if you're going to do something in the name of fuzzing, make sure you do it well. So implement it in a way that it doesn't break. Why? Because whoever uses it will actually break that API. Tell the user what you're putting on the wire. Especially in the security domain, it's very often that I come across tools and I don't know when I hit start, select, enter, what's happening unless I have a Wireshark session in the background capturing all the results. That's very important. Don't obey the protocol that you're fuzzing. There's no reason to obey the protocol that you're fuzzing. All you're interested is to see what responses it gives back. Whether or not the data is encoded in the right language, well, yes, okay, it does make a difference. And ideally, you would want that information. But for someone that knows what they're after in terms of the payloads that they're putting on the wire, encoding of the data coming back shouldn't be a problem. And put some trust in the core to generate these payloads. So if we go back to the actual user interface now, it should make a bit more sense. We have control of a head request that basically includes all the payloads which are added onto this as fuzzers. We can see what goes on the wire, and little things like return characters are actually converted to \r/n, and you have control of this. And finally, you get responses back, and you can graph these responses. So all of a sudden, it all starts tying in. Okay, that's all very good. And scripting is also very good, and I briefly touched on this, but how would someone wanting to use Java for fuzzing actually use JBroFuzz? Well, it's a two-step process. You'd have to use this iterator class of the fuzzer, and you would have to go and access this file here, which contains all the payloads. You can implement your own in here. Having done that, then it becomes, regardless of the actual payloads that you're using, it becomes a 15-line code exercise. So, okay, this example again is hex, straightforward, but we can replace this with we can replace this ID with any of the IDs that we have here in the payloads category. So, when you're implementing a public API, especially for the process of fuzzing, make sure that what you're giving actually simplifies what the user is trying to achieve. And again, it doesn't matter if it's URI exploits, or it would just be 15 lines of code that actually trigger the scripting vulnerability, the scripting process around generating these values. Okay, so what are you going to see from JBroFuzz in the future? Well, little things like an installer, which has been implemented in version 1.1, support of different authentication, NTLM, basic, etc. Being able to proxy, and also focus on being able to graph these results in many different number systems. So the example that I gave you before, if you actually look at, let's just send one request here, and again, if the connection, yeah, I can see some traffic. Okay, so we're going to get a single point back, but actually graphing the responses in a meaningful way is very beneficial when you're dealing with 20,000 responses. So over here, you've got the file size of what's coming back, and that probably varies, and that's a hint of what's happening, but that's not a set metric, because quite regularly that will vary in a way that's not dependent to the process of fuzzing. So there's a hash value, so we're hashing the response that we're getting, and we're seeing how much it changes by summing up the hash every time that happens. And that's normalized to a value of 0 to 1,000. That's actually more useful. You can catch Apache date timestamps in a normalized graph. So in terms of the roadmap, these are the areas that we're going to spend more time in the future, and there's also talk about merging this project and using it within other tools, etc. Conclusions, well, if you choose to implement a fuzzer, make sure that you make the process of fuzzing as transparent as possible to the user. No one wants a fuzzer that they don't know what it's doing. No one wants to be logging TCP traffic without relying on the particular tool. Don't obey the protocol that you're fuzzing. Instead, obey the APIs which are being used. Otherwise, you won't be able to reach the protocol. And report the results in a meaningful way. There's a lot of work to be done in our industry in that particular area, especially around metrics. And do allow for iterations around this whole process of fuzzing, addition and subtraction of payloads, changing the values, etc. Are there any questions? Yes?
How does your tool deal with different codecs? Like, one question I had with your tool is, if I wanted to send something with KS7 or 1632, can I do that with your tool?
Yeah, absolutely. So if we look at the UTF-8 here, for example, those are the accepted characters. Now, that would actually give a UTF, so let's say we make this 16, that will send a UTF-16 response, and that will come as an accepted char set. That will come back. It will be stored on file as a normal UTF-8 file, but the actual bits which get truncated are still in the file. So there will be some differences, but it won't actually register the UTF-16 characters, because then you get in all the different categories of char. Ah, okay. So, no. So you want basically half of this to be UTF-8 and the other half. Well, remember, we're fuzzing HTTP, so you're not meant to be doing that. Again, okay, it's definitely a feature worth considering. Yeah. How would you actually implement that? Probably, I'm just thinking out loud here, so you'd probably grab all this as... Oh, no, the socket is fine, but how would you actually implement it in terms of payloads and fuzzers? So, yeah, so all this would have to be encapsulated in one encoding type. Okay, yeah, yeah, that's... to convert to. Yeah, that's a bit. But then you need a mapping between replacive fuzzer and the actual characters that you're writing.
And that would be impacted by like the
More length, yeah. Interesting. No, I'll definitely take that into consideration. So. At this stage, no, because you would probably know what you're putting on the wire in terms of, let's say that we find the SQL. I think I can see where you're going with this. Yeah, exactly. So you probably want to encode that as a %20, right? I think a feature that just come to mind is the ability to select some text and right-click and say encode to a variety of different. Right. Yeah. So what would you include in the right click? So UTF-8, 16, ASCII. all the main character encodings. Yeah, anything that can be. Okay. No, I'll definitely take that. Thank you. Definitely take that into consideration, guys. Any other questions? Okay. Thank you very much.